Hi, so I'm going to talk about how to use machine learning to build a model for predicting the power plant output. So for this, I'm going to use Jupyter Notebook, and I'm going to use the Scikit-learn library and the Pandas library to do the data analysis and creating the model. So first, what I'm doing over here is uh, I'm loading the CSV file that is provided, and I am loading the data in a data frame, right? Then I'm describing the data over here to see what are the various columns and how the values look like. So after that, what uh, I'm doing over here is I want to understand how the different variables are loosely connected to each other, how they're correlated to each other. So what I do is I plot a scatter matrix, which basically uh, is a grid of the different attributes and shows how these attributes are kind of correlated with each other. Similarly, I also uh, plot a heat map using the Seaborn library, and this heat map kind of shows the different numbers that signifies how strongly the different variables and attributes are correlated to each other. So from this heat map, it is apparent that PE, which is the target attribute over here, has a very strong negative correlation with AT and V, and sort of a weak positive correlation with RH and AP. We are also plotting a pair plot, and from this, it is kind of apparent that the negative correlation between AT, comma V and PE, and the weak positive correlation between PE and RH and AP attributes. Uh, so, what kind of modeling approach are we going to take? So PE, which is the power output that we intend to predict, it is a continuous variable, right? And the data set that is given to us, it's already labeled. So we know the values of the attributes ATV, AP, and H. So this is clearly a supervised learning algorithm. Uh, now, what we're gonna do is we are gonna first uh, take a data frame with ATV, AP, and PE, and we will try to create a model based on that. And the second data frame will have ATV, AP, RH, and PE. So in the first data frame will not have RH as the attribute, whereas the second data frame will have all the uh, data attributes, including the target attribute. So we're gonna first create these two different data frames. What are the different error matrix that we're gonna use? We're gonna use the mean square error and mean absolute error to finally evaluate the final model. The modeling approach will be as follows. So we will take the first data frame, we will divide it into a 90 is to 10 ratio. We'll split the data into a 90 is to 10 ratio, where 90% of the data will be used for training and the 10% will be used for testing, right? Using this 90% data, training data, we will adopt a tenfold cross validation approach to create three different models: uh, decision tree, random forest, and linear regression models. And we will evaluate these models using the mean square error, mean absolute error, and mean absolute percentage error. Uh, we will select the model with the best performance, right? And we will repeat the same process with the second data set, which contains all the attributes. Uh, then, using these six different models, we will select the one model which shows the best performance. And once that model is narrowed down, we will use the final test data to evaluate that particular model. So this is what we have done over here. So as you can see, the first data frame, which comprises of ATV and AP and PE, is being taken. We are we are taking the ATV AP as the X attributes, and the Y attribute is the PE, which is the uh, target attribute. After that, we are using the train test split to uh, divide the data or split the data into the training set and the test set. Using the scikit-learn model, we are creating a linear regression model, uh, and then we are using a tenfold cross-validation method to compute the three different matrix of the model. We are doing the same thing with the training data, but we are using a decision tree algorithm and computing the three different matrix as well. And at the last, we are using the random forest model to also compute those three different matrix. Uh, if I if I if I just consider data frame one, I can see that the random forest algorithm is the best algorithm uh, with the best performance matrix. Uh, Now I repeat the same process using data frame 2. So I take the data frame 2, uh, the X attributes are the data attributes, and the Y attribute is the target attribute. Uh, I use the trained test split to split the data into the training set and the test set. Using the training set, I am creating a linear regression model using a tenfold cross validation method to compute the three different matrix: the negative root mean square error, the mean absolute error, and the mean percentage error. Uh, Following the same process to create a decision tree model and also a linear regression model, right? Uh, and when I compare the six different models, I see that the best performing model is the one that was created using data frame 2, which means it comprised of all the data attributes. And the best and random forest was the best performance algorithm. So the model that was created using the random forest algorithm, using all the data attributes, uh, was the best performing model. So we have narrowed down the model, and now we are going to evaluate the model with the test setup or the test data that we had initially created before the model was trained. So how do we evaluate the model? So we take the model, we using the test data X test 2, we predict the Y attributes, and then we compute the mean absolute error and the mean squared error using the Y test 2 and Y pred 2, which means the using the test at using the predicted using the predicted values and the original values of the data that was available. And that is how we evaluate the model. Thank you.